Hey guys, I want to go through one of your homework problems that deals with drawing molecular orbitals for conjugated pi systems. So this is a triene, so that means we have 6 pi electrons to deal with. Those pi electrons in this system are shared across 6 carbons, and so there's 6 atomic p orbitals that we have to combine, and that means we're going to wind up with 6 molecular orbitals at the end of the day. So I've already gone ahead and drawn out the template. We're going to think about different ways we can mix 6 atomic molecular orbitals to make molecular orbitals. The easiest one to come up with is the lowest energy molecular orbital, and that's where all of the systems are equally in phase, where overlap can happen across all 6 of the p orbitals. And so that's a situation that gives us psi 1. That has no nodes because we have happy overlap with all of the 6 p orbitals. Equally easy to come up with is the highest energy one. That's where all 6 of them are out of phase, and so we have alternating signs on the p orbital lobes, and nobody lines up happily, so we have nodes in between all 6 of the p orbitals, and so the top highest energy one is going to have 5 nodes. And so we'll increase in the number of nodes as we go up this system, so we should expect to have 1 node in psi 2, 2 nodes in psi 3, 3 nodes in psi 4, and 4 nodes in psi 5. And so the easiest way to come up with a single node would be to do 2 sets of 3s, these in phase in this way, and then the other one's in phase but opposite the first 3, so that passes 1 node right down the middle of the system. The easiest way to come up with 2 nodes would be to have pairs of orbitals in phase but switching between the 2 pairs. So these would be in phase, these would be out of phase, these would be back in phase. And so we would have 2 nodes that pass in those 2 positions with psi 3. Psi 4 requires us to have 3 nodes. And so in this system what we would have is lone orbitals on the end. We can put 2 in phase here, switch the phase of the next 2, and then have the last one as a lone out of phase orbital. And so that will pass a node here, here, and here. There's the 3. The final one with 4 nodes we can get by having 2 sets of lone orbitals. So this one will be out of phase with its neighbor, that's 1 node. We can put this one now out of phase with this pair, that's the 2nd node. If we put the next one, the 5th one, out of phase with the central pair, that's the 3rd node. And then the 4th node arises by having that final one out of phase. And so here we have 4 nodes in psi 5. If we're going to populate the 6 pi electrons that we have, we start at the lower energy orbital and dump 2 into each orbital until we run out. What that gives us now is psi 3 as the highest occupied molecular orbital, the HOMO, and then that makes psi 4 the lowest energy unoccupied molecular orbital, the LUMO.